Hey guys, welcome to Conceptual Geometry, Lesson 5.7, Coordinate Geometry, Triangle Proofs. Well, that sounds more complicated than this is actually going to be. We are going to use formulas, actually just one formula, distance formula, that we've already learned, and just apply it to a triangle. So scalene triangle proof. What do you guys know about a scalene triangle? Hopefully you remember it has no equal sides. Therefore, we have to apply three distances and show that they're all different. Okay? An isosceles triangle proof. What do you know about an isosceles triangle? It has two equal sides. So again, all we have to do is use three distances, and two of the three will be the same. Right triangle proof. What do you know about a right triangle? Well, the first thing that comes to mind is it has a right angle, and you're 100% correct. That's a little bit hard to show using coordinate geometry. We can do it, but we want to use the length of the side. So if you remember, in a right triangle, a squared plus b squared equals c squared. The reason that I like to use that method is because we can also use three distances. So if you notice, for every triangle proof, we are just going to use three distances every time. Now, one of the things I'd like you to remember about that, because I'm like, well, what's A, what's B, what's C? That this is really leg squared plus leg squared equals hypotenuse squared. Because our triangles aren't going to be labeled A, B, and C, you have to understand that these two are the smaller two sides, and this is the longer side. All right, let's get right into it. Prove triangle HJK is scalene, and it's already graphed for us, and they have the points labeled here. Now, if you remember, our distance formula, the one I like to use, is D equals square root delta x squared plus delta y squared. That should be on your formula sheet. You can look at that as you do this problem. So it doesn't really matter what order we do this. I need to find the distance of each side. So let's start with HJ. Well, look at HJ. That's kind of an easy side to find the length of because it's vertical. Anytime your side is horizontal or vertical, we just count. So this length here is 3. If you want, you can put parentheses count afterwards so you can just tell me how you found that length. Next, let's find the distance of JK. Again, order does not really matter here. Now JK, I can't count because it has a slope other than 0 or undefined. So I want to make a right triangle. This side is 1, 1, 2, 3, and that side is 4. So my delta x is 4, my delta y is 1. To find the distance, I take the square root of 4 squared plus 1 squared. You would put just this in your calculator, or you can evaluate that mentally. That's 16, and that's 1. 16 plus 1 will be 17. So that side is square root 17. And then lastly, I'll find the distance from H to K. So that's this triangle here. Draw in your two legs that make the right angle. 1, 2, 3, 4. Delta x is 4. 1, 2, 3, 4. Delta y is 4. So this would be square root 4 squared plus 4 squared. So again, I would throw this into the calculator, or that's 16 plus 16, which is 32. So this side is square root 32. Now, compare. This side is 3. That side is square root 17, which is not 3. That side is square root 32, which is not square root 17, nor is it 3. So all three of these are different. You wanted to prove it's scalene. We did that. We just have to explain. Triangle HJK is scalene because it has no equal sides, or none of the sides are equal, however you want to explain it. All right, how about one that is isosceles? So here, again, it doesn't matter where you start, but usually I like to try and eyeball this and see if I can tell ahead of time which two sides are going to be the equal sides. It doesn't really matter what order you do this. I just, being a math teacher, like to do the equal sides first. So it looks like these are the two equal sides. So I would start this distance of JH. That's this side here. So let's make our right triangle. Delta x is 2. Delta y, 1, 2, 3, 4, 5. So this will be square root 2 squared plus 5 squared. And again, I recommend you put this into your calculator. All right, that's a 4. That's a 25. 4 plus 25 would be 29. I get square root 29. All right, let me color code these. Next, I'll find the distance of HK. So that's this side. Make your right triangle. Delta x, 1, 2, 3, 4, 5. Delta y, 4. So that's square root. 5 squared plus 2 squared. Sorry, my bad. That's a 2. I'm getting ahead of myself. 2 squared is 4. Obviously, those numbers are the same as what's up above, so that would be square root 29. And the last one, JK. And it's not good enough to stop here. Some of you might ask, well, I just have to do 2. Those are equal, therefore it's isosceles. Well, you have to show it's not equilateral. So we have to evaluate this third side, and it will not be the same as the 2 up above. All right, so let's see that. Find this side here. Make your right triangle. Delta x, 1, 2, 3, 4, 5, 6, 7. I got 7. Delta y, I got 3. So that'd be square root 7 squared plus 3 squared. So 7 squared is 49. 3 squared is 9. 49 plus 9 is 58. Again, I expect you just to do this on the calculator. Now, what do we notice? Compare those. These two are equal. So if these two are equal, what we would do next is we would just make an observation here that JH equals HK. And then lastly, triangle HJK is isosceles because it has 2 equal sides. So there's an example of how you prove an isosceles triangle. Last one. Prove triangle HJK is a right triangle. Okay, so this is going to be a little bit more challenging. And again, you don't have to do it in this order, but I like to try to identify the right angle ahead of time. So that looks like a right angle there. I'll use the distance formula on those two sides first. All right, distance of JK. All right, so here's JK. It's pretty easy to count those sides. Delta x is 3, delta y is 2. 3 squared plus 2 squared. If I put those into the calculator, 3 squared plus 2 squared is 13. So the distance is square root 13. Next, let's do the distance of JH. So JH is this side. Delta x is 2, delta y is 3. So it's 2 squared plus 3 squared, but notice the numbers are the same as up above. I've already done that. That's square root 13. And the last one will be the distance of HK. So there's HK. Make your triangle. When the triangle's long and narrow like this, make sure when you're counting the one side, you go all the way up to the coordinate. So delta y is 1, 2, 3, 4, 5. That would be 1 squared plus 5 squared. 1 squared is 1, 5 squared is 25, 1 plus 25 is 26. Now, I know it's isosceles, but it doesn't ask for isosceles. It asks, is it a right triangle? So what we have to remember here is a squared plus b squared equals c squared. Now, you don't have to write it out, but what you have to remember in this theorem, these two right here are the legs. And that means the smaller two sides. So even if you didn't do this in order, you have to pick the smaller two sides to put here. And then the hypotenuse is the longest side. Here's how it's going to look. The smaller side, or one of the smaller sides, square root 13 squared, plus the other smaller side, square root 13 squared, equals the hypotenuse, or the longer side, squared. So this is a property that we did in algebra, but we haven't really done in this course, but it's a pretty simple concept. The square root of something squared, basically what happens is the square and the square root cancel out. So this expression right here is just a 13. So in the next step, you would just show me that's 13 plus, well, square root 13 squared again is just 13. square root 26 squared is just 26. And then you ask yourself, is this a true statement? Is 13 plus 13 equal to 26? Yes. So if yes, you've just proved it's a right triangle. I put a little check mark there. Now, how do you explain it? It's a little bit harder to explain. I would say triangle HJK is right because you can't just say a squared plus b squared equals c squared. You have to list the actual sides. JK squared plus JH squared equals HK squared. All right, so use those. JK squared plus JH squared equals HK squared. So you can see that the right triangle proof is going to be the one that's a little bit more challenging, but the good news for you guys is it's the same process every time. 3 distances, show that they work in the Pythagorean theorem, and then use this explanation. Okay, guys, thanks for watching the video. That concludes day 7. You now have all the information you need to complete homework 7. As usual, though, if you have any questions, don't hesitate to reach out. See you in class soon.